Hello everyone, welcome back. Today we are going to solve Coordinated Sciences, the physics part 0654, paper 42, May, June 2026. So let's see and let's check with me please to guess what will be your mark for this paper. Here we have topics related to motion, waves, electricity, nuclear physics, and I will go through every part with full explanations. Okay, let's get straight into it and see. Question 9, this is the first question for physics. State the difference between speed and velocity. Number 1, we know that speed is a scalar quantity and velocity is a vector quantity. Okay, so you have to say that and to explain. So speed is a scalar quantity. And what does it mean, scalar quantity? It means what? It has only magnitude. Okay, magnitude, or what we call it size. Okay, magnitude only. So how about velocity? Velocity, it's vector quantity. If you remember, guys, my students will remember that we practiced many exams and we had almost the same questions before. Not only this question, but even most of the exam. And this question itself, it was exactly the same, and it's repeated question. Okay, so when you talk about velocity, it means it has both, okay, the magnitude and direction. Okay, most important to mention the direction. Okay, so done with these 2 points. Then the graph, and this graph it was very popular in paper 2 in multiple choice, increasing, decreasing, and so on. So you will see, describe the motion of the car from 0 to 10. So from 0 to 10, from here to there, you will see here that this one is acceleration. Okay, so this is acceleration. This is only 1 point, and yes, it's acceleration, but also you have to see this acceleration, since this is curve, this is not constant acceleration. So don't write, if you wrote in exam constant acceleration, actually this is incorrect. Okay, so if it's a straight line, yes, it's constant acceleration. But if this one, as you see, it's curve, this curve in this case, this is like decreasing acceleration. Okay, but if this curve was something like this, so this one is increasing acceleration. Okay, so this will depend on the mark scheme, but I believe in the mark scheme that if you write constant acceleration, it will be incorrect. You should write decreasing acceleration. I hope if you write acceleration only, you get 1 mark, but I think the best answer to do is to write decreasing acceleration, or at least to write non-constant acceleration. Calculate the acceleration of the car between 15 and 30. Okay, so they ask us to find acceleration, so it means that this one, it will be straight line. Okay, because this part from here, and this what you have in your IGCSE syllabus, from 15 to 30. Okay, so this part. So since it's from these 2 points, and as you see that these 2 points already exactly on the point, like the coordinate, it's integer coordinate. So use these 2 points to find the gradient. And as you know, the acceleration in speed time graph, is the gradient. Okay, so you have to find the rise, this rise over run. Okay, or take any 2 points if you wanted to make y2 minus y1 over x2 minus x1, like that, no problem, like dv by dt. Okay, so let's see, this point is 2 and this point here is like 1.25, between 1 and 1.5. So this one should be 0.75, right? So this is y-axis, this is the dv, okay, the difference in velocity. And this one here 30 and here is 15, so this one is 15. Okay, so this is dt, seconds, right? And this one meters per second. So if you want now to find the acceleration, you have to write the formula, please, as every time I remind you, the formula of acceleration or the gradient is dv by dt, or this one, the rise over run, it's 0.75 over the 30 seconds. Okay, and we are sure that this is meters. Just to double check, this is meter per second and this one is per second as well, so it will be meter per second squared. Okay, so let's see, 0.75 over the 30, the answer should be 0.025, 0.025. so this one is the acceleration. Okay guys, the formula, substitute in the formula. Don't forget the unit. The unit already given, so no problem about the unit. Okay, so this is the answer of this question. Okay, how about next one? This is 15, yeah, 15. Oh, just, okay. Look, I wrote 15 here, but I don't know why here I wrote 30. Okay, so just, please guys double check usually, because sometimes we write numbers and we take different numbers. Yeah, take care. Here is 15, 30, and we said it's 15, so this is 15. Okay, so the answer should be 2 times, okay, 0.05, okay. So usually guys, double check your calculations if it makes sense or not, and especially after you finish the exam, you will have time to revise calculations. Okay, double check usually and try to show your work. Showing your work here will decrease your mistakes, because you look here, I wrote 15. Oh yeah, it's 15. Okay, now next one, done with this. Okay, during part of another journey, the acceleration of the car, so this is the acceleration, this is a, it's 5, the mass, this is m, 1.2, okay, kilograms, and the driving force applied by the car, so this is the force, driving force, okay, just to, this is driving force, is 10.5 newtons. Calculate the magnitude of the friction forces acting on the car. Okay, what we know that in the Newton's second law, that F, let's make the triangle, that F equals to M times A. So F should be M, it's 1.2, let's write the formula, M times A. So 10 point math, 1.2 times 5. Okay, so this one should be 6 newtons. Okay, so the car needs actually 6 newtons, but the driving force supplied by the car is 10.5. okay, it means the difference between them went in the friction force. Okay, the difference between both. So the force what we need is 6, so the friction now will be the force of friction should be the driving force, which is 10.5 minus 6, okay, and this will give us the 4.5 newtons. So this one 4.5. Okay. Next one, when the car reaches maximum velocity, its kinetic energy is 2.2 joules. Calculate the maximum velocity of the car. So in this case, the kinetic energy, we know the formula, 1/2 mv squared. So this is 2.2, 1/2 m, the mass, which is 1.2 times v squared. So this one is 0.6 v squared, and here's 2.2. So if you divide 0.6 by 0.6, okay, so v squared equals to this number. So v, take care that you need v, so you have to take the square root of this one, okay? So let's make it 2.2 over 0.6 and the square root of the answer. So it should be like 1.9, okay? 1.9. This is the answer of this one. Okay. The unit, say, okay, good, it's given here. So 1.9. Okay. Two significant figures, okay. Two significant figures, fine. Next question, question 10. State one use of ultraviolet radiation. So I know that most of you wrote an exam mostly sun tanning. Okay, that's fine, that's correct. So you can write that, no problem. So if you want to write that sun tanning is okay. If you in tanning beds, that's fine. If you want to write in disinfecting water or surfaces, like sterilization, okay, that's also okay. So like anyone, it's 1 point, so you need only one, okay? Disinfecting water, it's okay. Or you can say sterilizing, that's good, okay? So I mean, you can write any of them. There is many, of course. Even there is detecting, for example, banknotes, if it's real or if it's forged, okay? State one harmful effect of ultraviolet radiation. And this is also from the notes what I was usually saying to my students. Please don't write it's very harmful. Don't say like, oh, it's dangerous, okay? So I said this many times. You have to be specific and write, for example, skin care. And I think we took similar questions like mock exam. We had like most of this question, it was mock exam. Okay. Next one. Complete the sentence to describe a longitudinal wave. Okay, so look here, they are talking about the direction of space is 2. So the direction of what? Okay, as we mentioned, the direction of the vibration. So you can write vibration. Okay. As we said before, oscillation or vibration. You can write anyway. So the direction of vibrations is what is parallel to the direction of the propagations. Okay. The ultrasound, okay, we said before that sound is longitudinal wave in general, so ultrasound stay the lowest frequency of the ultrasound and include the unit. So to get 1 point, you have to, don't forget the unit. So the lowest frequency is 20,000 hertz or 20 kilohertz. Okay, don't forget the unit. You may write like that, or you may write 20,000. It's also fine. Okay. Now, as we described in the revision before this exam, that you should know that the longitudinal wave has compressions and rarefactions. So you have to explain the difference between them. Oh, compressions in pressure. Okay, so in compressions, since they are very close to each other, it means they have more pressure, and refraction it will be less. So in these 2 points you have to explain that. So you can say that compression, and you can, by the way, draw. You can draw as usual. I say if you can make a diagram, this will be much better after explaining. Okay, so in compression we have regions, okay, where like particles are very close, right? Particles are closer to each other. So if they are closer, what does it mean? It means this one, it means more, means it's more like dense, okay? Or you can say, of course, it's more dense and more, okay, pressure, or higher pressure, huh? Higher pressure, okay? But when it comes to the refraction, refractions, we have regions, yes, but those regions are like spread apart from each other, right? Are regions where particles are spread, okay, apart, okay, or what we said, it's less dense, yeah, less dense and less, of course, pressure, okay. So this is the, if you want to sketch them, as we, if you remember, we did like something like this last time, and we made something like that, and again we made again the refraction. So if you wanted to show this, that this part, for example, is compressions, and this part is rarefaction. Okay. Now, next one, complete ray diagram for converging lengths. So this type of questions we did many before related to this one, and usually we draw 3 rays and 2 are enough. So the first one, of course, you have to use roller, okay, and good here that you have grad, so it's easier to make it correct and accurate. So if you have the parallel line parallel to the principal axis, this one will be refracted to the principal focus. So this one should go to F. Where is F? Is here, okay. So something like that. And if you have another ray, or you draw another ray from the top and continue, okay, to the center, and what? When you continue to the center, take care that no refraction, okay? Something like that. Okay, so the intersection point, this is where the image will be created, and as you see, this image is, if you talk about the characteristics, it's inverted, it's real and smaller size, smaller than the object. Okay, so here they said mark the location of the image with arrows. So this is, you have to mark it, and this is the image. Okay, so we did that. So the 3 points, the 3 points will be for the 2 rays, as we did many times. It will be for the 2 rays and for this labeling of the image. Okay, you don't have to write the characteristic, they didn't say that. Okay, question 11, electricity. Question 11, state the change in the resistance of a metal wire when the length of the wire doubles. Look, this one also in the revision we mentioned that the resistance, the factors affecting the resistance, we made it in this formula like rho L over A. And mainly we talk about rho because we will have the same wire, so this rho will be the same. So usually we are talking about L and A. Okay, so when the length of the wire is doubled, so what will happen to resistance? It will be also doubled because R is directly proportional to the length. So if you double the length, it means what? It means the R doubled. So just writing R doubles, that's correct. Okay, and it's inversely proportional to A. Okay, wire A has a length of 45 meters and a resistance of 12.6. Wire B are made of the same metal, so we're not talking about rho now. So as wire rho is the same as wire A and has a length of 45. Okay, so it means both of them, they have the same material, same A, rho, the same L. Okay, so now the only difference will be in A. So length, it's the same. Wire B has twice the cross-section area. So if you say that rho here, they said that the cross-section area is twice. So look here what will happen, that this A, it's twice. So what will happen when you make this one twice? If rho and L are the same, it means this one, it will be halved. Okay, like 1/2. Okay, so determine the resistance of the wire. So the resistance will be halved. So what is the resistance? 12.6. So divided by 2. So it will be just 6.3. Okay. Next one, the 3.6 volt cell is connected across 3 resistors as shown in figure 11.1. Calculate the total resistance of the circuit. To define the total resistance, you need first to find the resistance here in parallel and then to add it to this one in series. So we have 1 over R equals to 1/20, 1 over R1 plus 1 over R2. Okay, so it will be 2/20. So it means that this R of this 2, take care, this is 1 over R. So it will be reciprocal, like 20/2, which is 10 ohms. So it is 10 of this 2. So if you will write equivalent one to this one, okay, it should be here the 10 ohms instead of this 2, and with this one the 40 ohms. Okay, so it means now that the R total equals to, now they are series, so this 40 ohms plus 10 ohms, so it's 50 ohms. This is 3 points. Okay, actually this one of 3 points is easier than this question of 1 point. Okay, Ah, that's okay. You have good that that one was 1 point. This one 3 points. Okay, calculate the current at point X in the circuit. We need the current where? We need the current here. So if you, let's make it in red. We're talking about current I from here, from the positive. So I is there. And I, some will go here and some will go there. I1 and I2. And as you know, they are identical. Okay, so if you know the main current here, just divide it by 2. Okay, because they are identical, so they will divide by 2, the same resistance. So in this case, since I know that this one, we said before that this one is 50 ohms, right? And this one is 3.6 volts, right? So if you want to find I, you should just use Ohm's law. Okay, what's Ohm's law? Our beautiful triangle that V equals to I times R. So if you want to find I, it's V over R. This is the main main current. Okay. So V is 3.6, right? Divided by R is 50. So this will give us the main current. Don't wait. Okay, don't be in a hurry. So this one is 3.6. Yes, just I'm double checking numbers. Sometimes we take wrong numbers. Okay, 3.6 divided by 50, so it will be 0.072. This is the main current, okay? This is the main current here. This is the main one, but we will need to divide it by 2, okay? So just to take this 0, so if you wanted to find I1, it's this one divided by 2, so just over 2. So it will be 0.036 amps, and the unit is there already. Okay, good. Now in another circuit, a 3.6 cell is connected across a single resistor. Okay, this is another circuit. We connected to a single resistor. The current in the circuit is 0.18 amps. Calculate the energy supplied by the cell. Okay, let's see. Do you remember, guys, we said that the power is E, the energy over time, okay, or the work over time. So from this one, we know that we need energy. Energy is P times T, okay? And also we know that P equals to V times I, this P, okay? So the energy, so V, we know 3.6. I is 0.18 times the time. 1 minute. In revision, we had exactly the 1 minute. It's the same. So just multiply by 60. Don't make it 1 minute, okay? So 3.6 times 0.18 times 60, that will give us 38.88 joules. So this is the answer. Okay, guys. So this is C. Now question 12, the nuclear physics. Okay, it's repeated questions. So if you look at this one, what we have here, the nuclide notation of a uranium isotope is this 92-235. So state the number of protons and the number of neutrons. Okay, so we know that this 92, right? And neutrons, we subtract them. So 235 minus this 92, which is 143. Done. State the relative charge in the nucleus of this isotope. Okay, if we talk about the relative charge inside the nucleus, it means we are talking about the protons. And how many protons? We have 92. So we have plus 92. Okay. How about inside? You know, the neutrons, they are neutral. So we have only the positive charge of the protons. The isotope undergoes nuclear fission. Describe the process of nuclear fission. Again, in the revision, we say the difference between fission and fusion. So in fission, like we have large nucleus, and this will absorb like a neutron, and then it will be split to two smaller nuclei. Okay, so let's see, or let's write. It's like a large nucleus, and when it absorbs a neutron, and this will lead to what? And then split. Okay, split it into two smaller. Okay. Okay. Then state a significant source of background radiation from outside the Earth. Take care here, talking about the outside. Okay, we're not talking about inside the Earth, because if you talk about inside, we may talk about the medical applications we have, a nuclear industry, and all of this stuff. But when you talk about from outside, you here mainly we are talking about the cosmic rays. Okay, this is what comes from the sun, from stars, or from any outside the space. Okay. Describe the most common nuclear reaction which occurs in the sun. Okay, we came to what's happening in the sun, which is the nuclear fusion. Okay, and here, since you have 2 points and we are talking about to describe, so don't just say nuclear fusion, you have to describe it. Okay, like let's define this one. It's like to fuse or to combine. Okay, when you have small, okay, and they will what? They will combine. Okay, combine or fuse. Combine, okay, together to form larger one. Okay, this like when you have in small ones, okay, like helium, okay, and this will hydrogen, sorry, and this will lead, okay, to the helium. Okay, so you have not just to write nuclear fusion, and you have to describe it. Okay, and what will happen when this when they combine or fuse? This will lead to what? To release huge amount, okay, huge amount of energy. Okay, now the moon orbits the Earth. Again, we talked many times about finding the speed, okay, or the orbital speed. So the moon orbits the Earth in a circular orbit once every 27 days. The moon travels at an orbital speed of this one. We have the speed now. So the orbital speed, it was like 2 pi r, okay, over t. And the speed of light they are giving, good that they are giving this unit for you, sometimes they don't. Calculate the time taken, but they give this one to you, it means you have to use it. Okay, if it's not given, you may think about it. You will think about it, but that's good that it's given. So it means you will use this one. Okay, you are going to use it. So this is good hint for you. Calculate the time taken for a radio wave to travel from the moon to the Earth. Okay, let's find this information to find R, because we need. But look here, because a radio wave to travel from the moon to the Earth, we need the time. So in this case, we have to find R first. Okay, S, let's rearrange this one. So, or we can say that, okay, that the speed is 1030 meters per second. Take care, meters per second. Okay, so this one you can't leave it 27 days. So 2 pi, and we need to find this r, and t is 27. And take care, 27 days times 24 to make it in hours, and then 60 to make it in minutes, and another 60 to make it in seconds. Okay, so if you make cross multiply, you will find that r equals to this 1030 times 27 times 24 times 60 over this 2 pi. Okay, so let's see to find r. So 1030 times 27 times 24 times 60 times 60 again, all of this divided by 2 pi. So the answer of r, if r equals to, it's big number, actually it's 3, this makes sense, 382,414.95. Okay, and this should be in meters. Okay, meters. So let's double check. 382,414.9. Okay, so this is r. Okay, so this is like the distance. Okay, this is the distance. So if I want to find the time, look, here is time, t small. We are not talking about the what this one, the let's go up. Yes, we are not talking about the 27 days, this like t capital, the periodic time. No, we need to find t, and t should be the distance over speed. Okay, do you remember that speed is distance over time, right? So time is distance over speed. Okay, the distance now, it's my r. Okay, 382,414.95. This is in meters, and the speed is speed of light, because actually this radio waves, okay, or all electromagnetic spectrum, they will travel by the speed of light. Okay, so 3 times 10 to the power of 8, and this one meters per second. So the answer in this case will be in what? In seconds. Okay, so let's take the answer from calculator. Answer divided by 3 times 10 to the power of 8. So the answer is 1.27. Okay, so this is the answer of this question. Next one, they think this is the last one. Yeah. Okay, the Big Bang Theory. Okay, we need to talk about it. State the Big Bang Theory. 2 points, so at least you have to write 2 statements about it. So, as we mentioned again in the previous video of revision before the exam, that the universe began from an extremely small, hot, dense point and has been expanded ever since. And the age of this universe is approximately 13.8 billion years. Okay, so just this what you have to write. Okay, so if you write 2 are okay. So the universe began from an extremely small, hot, dense point. Okay, and so this is the first statement, and has been expanding ever since. Okay, this fine. Yeah, these 2 points are okay. It's, if you know more, it's better to write that the age of the universe is 13.8 1.8 billion years. Okay. Hopefully this exam was useful for you. And now please write in comments like what do you expect to get in physics or to get in coordinated sciences in general. And please like and give me a comment, subscribe. Okay, thanks so much. See you in the next video. And you may write in comments like if you want me to solve a specific question in math or physics. Thanks so much. Goodbye.